So, hey guys, how's it going? Am I peeking? Double check to make sure I'm not peeking on the right-hand side there. Am I good? Okay. So, welcome guys. Can everybody hear me at the back? Yeah? Awesome. Perfect. I'm going to try not to yell into this, but welcome to the May event for HTML Toronto. Big round of applause this month for all of our great sponsors who I have listed below, as well as Polar Mobile. You guys seriously knocked it out of the park for this one here. We missed April because there was so much going on in this city in April that I decided to push it back, and what we will do is we'll continue through the summer instead of skipping a month over the summer. So thanks to our sponsors for making this possible. Seriously, we really wrapped it up and put everything together. We're doing a massive, massive load on live stream and Justin TV, live streaming this out to the world. So we're showcasing Toronto and its talent. Specifically tonight, the team at the TVO Innovation Lab. These guys have been doing an absolutely amazing job over the years developing technology. Yes, round of applause. For myself, this has been a really big, kind of an inspirational project or inspirational presentation. I'm really, really proud of the group and how far it's gotten so much, or how far it's gotten over the past couple of years, to the point where somebody like TVO approached us as a group and said, hey, we're doing this really cool technology, we'd love to demonstrate and showcase it. Kind of approaching us as like, hey, can we come and look at this? Because of the fact that we're doing so much in the community, because we're giving so much back. I don't know about anybody. Raise your hand here if you used to watch TVO growing up. Yeah? Almost the whole room. How much has it impacted you? Right? A lot, right? It made you who you are. You were growing up. Pokeroo. Anybody remember Pokeroo? Yes! Exactly. So we were trying to get a Pokeroo thing here, but it started raining. We're not going to have that, unfortunately. But I'd rather it not get damaged. So big round of applause for them. In fact, this is picking me up on this. Big round of applause. It's truly an absolute honor to have somebody like TVO come in and do a presentation with us. So with that being said, I don't want to be praising too much because their heads are going to get really big. Welcome, everybody, first. There's food and drinks in the back still. We got tons of it back there. I just spent an hour at Sobeys trying to get the food because they didn't actually prepare it even though I ordered it. But I'd like to invite up to the front some of the sponsors to say a word. First, starting with Awanda. So Awanda is, where are you? Over there? Awesome. So make your way up. Say a quick word. And then we'll run through the sponsors, and then I want to give everybody a chance. Whoever wants to have a chance for winning one of the developer kits from LeapMotion. We've got 2 developer kits to give away for the people that are in the room. All you need to do is pitch your idea, and we'll be judging it. We will judge you on it. The 2 best ideas have a chance to get the developer kits and Skype time with a LeapMotion engineer in San Francisco to further develop and brainstorm it. So again, thank you, Awanda. Here you go.
Hi. Thank you. So I'm Jerome. I work at Awanda. We're pretty excited to sponsor HTML Toronto, and it's a way for us to give back to the developer community that helped us thrive. If there's, so what is Wanda? I'll just keep it quick and short and sweet. Wanda is a foreign exchange trading company. So picture buying and selling stock, but instead you're doing this with currencies. Forex exchange is a very big market, so this is why it's of interest to us. And we're a big player in the retail industry, but in the retail segment. But we're also looking at filling other opportunities. Maybe the biggest interest for you guys is that we have an API that we are opening, so you can build your trading applications on top of our stack, and it's a great place to work at. So we're always looking for amazing people to onboard. So if it's any interest to you, you can talk to Mark, to myself, or visit jobs.wanda.com at the end of the presentation. Enjoy.
Thank you. Can we actually get DigiFlare up? DigiFlare. Behind the...
Hi, everyone. Thanks very much. I don't know if you know DigiFlare. My name is Lanny, and I'm Creative Director at DigiFlare. We're a full-service digital agency, and I'm excited to sponsor this event and to speak to you guys as creative technologists who are on the cutting edge and the forefront of what's happening today in consumer technology. We share that space. From iOS to Android to Windows 8 to Xbox, we're really working on the cutting edge. If you saw the Microsoft Xbox One launch the other day, we're working on Xbox One projects right now. So really we're here to support the HTML5 community and also to invite you guys that if you're interested in working with an agency, we're hiring, growing, and we're looking for amazing, talented, exceptional people. Hopefully you are one and you can speak to me. And if you're not one, maybe you know someone who is and get them to talk to me. So I'm going to be milling about. This is our banner so you can check us out. And please feel free to contact me if you have any questions or are interested in any opportunities. And other than that, we're really happy to support Matthew and the efforts of HTML5 Toronto. Thank you.
Thank you. Appreciate that. Really kind words. Next, we've got a brief little mention here from Mars Commons, the Jolt area at Mars. They've been doing a help for publicizing and helping us out. As you know, we were in Mars quite a bit recently, doing all of our events. Unfortunately, we've kind of outgrown them for this event, seeing as it's about 100, just under 100 people here. But thank you to them. And here's a little bit about what they're doing for their next Jolt. I'll let you name this.
Hi guys, Matthew made me come all the way here. I think some of you guys are always hanging out in our space. We are looking for our next crop of startups, or our next cohort of startups for our fall 2013 cohort. If you don't know much about Jolt, we're actually a early stage tech accelerator based out of the Commons. We invest up to $50,000 in seed capital for about 9% in equity. And we provide 6 months of office space, 6 months of mentorship and workshops, and a whole bunch of things that happen within those 6 months. And it's all leading up to your demo day. So it's sort of our version of Y Combinator in the Techstars program. What's different about us is that we integrate you into the Mars ecosystem. So when you're finished with the program, it's not, you don't graduate and leave. We immerse you fully into the ecosystem. Mentorship continues on for about 12 to 18 months or until you raise your Series A. So it's a very immersive mentorship program, and we are looking for some of the best Canadian companies and startups. So the applications are open. If you have any questions, please do. You can email me. Matthew will send out my email. We've got some info cards here. You can also come and check out the space again. We have an info session on Monday with more information. Yeah, I mean, applications go into the hundreds, so it is a bit of a competitive process to get in, but we are looking for amazing startups and amazing teams. So Matthew, you said that the HTML5 group is a great group to promote this too. So we're here, and we're definitely, I mean, you can find us in the comments for more questions. All right, thanks guys.
Thank you. So there's two sponsors here that couldn't make it tonight. First one up is Kendo UI, who had sponsored us way back in the past, but we're now sponsoring us going forward again. This is the same guys that did Telerik. Really cool stuff that they're building, really cool things that they're having. We have tonight not only a bunch of T-shirts to give away for these people, for you guys here, but I'm going to say the best tweet tonight in regards to the content from TVO, that could be anybody, including people on the stream, gets a full, complete license to Kendo UI. Cool? Everybody familiar with what Kendo UI is? It's that HTML5 complete package. It's like it's like Bootstrap, but you have a lot more into it, right? You have form fields, you have all these different things. It's a complete package for building web applications using HTML technologies. So the best tweet out tonight, comedy-wise, education-wise, inspiration-wise, gets to have a license of Kendo UI, the complete package of that, the full version of it, to either anybody here or anybody on the stream. So next one up, somebody is the WebNut War team from Microsoft. So big thanks to these guys. They come in, they're supporting us for the full year. Really helped us out at the beginning of this, helped us get all started. Big shout out to them. If you guys ever get a chance, I do recommend the tweet. Thank you for supporting the HTML5_Toronto group. I won't hold IE less than 10 against you too much. So with that being said, I want to get things started with one last presentation, actually, from Polar Mobile, just to give, where is he? There he is, there, sorry. This is the venue we're at tonight. So big thanks to them. They stepped in. We were trying to find a location that was going to be big enough to accommodate this many people, have the bandwidth capable of streaming, and you guys really stepped it up. So thank you truly for that. And here's my.
Hi everybody, welcome. My name is Michael. I'm the CTO here at Polar, and we're super excited to host HTML Toronto tonight. The community is amazing, and there's just a fantastic evening ahead of us. The Polar team builds a software product called Media Everywhere. And what Media Everywhere does is it's a software development kit for creating media-focused mobile sites and apps. And a big component of Media Everywhere is the UI framework. Our UI framework is 100% built with web technologies, HTML5, JavaScript, CSS, but it's architected very much like Apple's UI kit, which is just an awesome combination of power and flexibility. What we're going to do, hopefully, is give a talk at a future meetup, go into a lot more detail about how we built it, what the code looks like, challenges we faced, and how we overcame all those different challenges from cross-device support, fragmentation, performance, getting memory usage to a really, really low level, and just general polish and smoothness. So we're going to do that hopefully at some point in the future. We're going to be really excited to give that talk. That being said, we are hiring. We're always looking for great software engineers, so if you are interested, please grab me or anyone else at the Polar team and talk to us after. Thanks, everyone.
Thank you. So I just found out that, well, I didn't really just find out. I was just reminded as such. We have 2 tickets to give away for Spotlight hardware for FITC. Woohoo! Right? Awesome?
Get excited.
Yes. New community manager for FITC as well. So I'm going to have her come up briefly while Matt is here. Matthew is here, Matthew Fab. So I'm going to have Matthew briefly talk about while I kind of quickly write the tweet that I want you to tweet to win the tickets. So, sorry, I completely forgot about this. In fact, I need to actually write the content. So Matt, come on up, quick. In front of the 650 some odd people that we have streaming as well.
Awesome. So, yes, I'm here to talk about FITC Spotlight. FITC runs various sort of technology events. They have Spotlight events, which are one day sort of focusing on one topic with one track. And so they're doing stuff on all sorts of different kind of hardware. They will be having a presentation on LeapMotion. They're also going to be doing Arduino, Raspberry Pi. Someone's going to be talking about Google Glass. It's a developer, Marcy, which I just recently got to try out myself, and she's done like a Bixby app where you could be riding on your bike and actually like get on Google Glass when you're approaching a station. If there's like slots on the Bixby bike, it's there. So she's going to be presenting. They are having this FITC Spotlight. They are having more presenters speaking over sort of less amount period of time, and then at the end of the day, they're having a sort of an hour hands-on with the actual presenters, where you can sort of work with them, take a look more at the various sort of different sort of hardware, and they're giving away 10 devices called Flora. Is that how it's? Which is Arduino compatible. Wearable, wearable sort of electronics. I often seen them sort of like interact with like LDAs and be able to sort of sew them into a piece of clothing to have some sort of interaction. So they're giving away 10 of those. So it looks like it's a really cool event. It's happening on Saturday, June 8th.
Yeah.
Yeah, just around the corner.
Discount code.
And we also have a discount code, HTML5 Toronto. 10% off the ticket price.
And early bird tickets end this Friday, so quickly, grab your ticket if you don't win one tonight.
And for, in case the people who are watching it online, the early bird ends when? What was it? Friday. This Friday. And so that is the tweet to...
24.
Okay. And so yes, this is, I guess we're giving away 2 tickets if you're interested in tweeting that. So.
Thank you. Appreciate it. FITZ. So, yay! It is now 1:15. I tried to make it under the 15-minute mark, and I think I did that. Without further ado, I'd like to bring up to the stage TVO. We have David. Sorry. I thought you were doing the pitches first. Yes, pitches. Pitches. We actually do have pitches. So. I think we should do the pitches after. We should do the pitches after, but then how are you going to get the public vote? Quickly. Sure, we can do the pitches afterwards. So this way, people, everybody raise your hand if you want to do the pitches afterwards, just so it gives you a bit of time to think about it. Yeah? Okay. There's enough people there that will do the pitches afterwards. Cool. So remember, remind me afterwards. So without further ado, David Newman from TVO.
Perfect. Thank you very much. Are we good to go here? First off, I'd like to say thank you for everyone coming out tonight. It's been really exciting for us to work through the process of developing or taking a Flash game, moving into HTML5, and then adding this cool new gesture technology. And also, before we begin, I also wanted to say a special thank you to Matthew. I've been coming to these events for quite some time, and working with him together on this event to see how it goes through, he puts a lot of effort and time goes into doing this. So I just think we need just another thank you to Matthew for putting all this stuff together. Can we get the slide?
Yes, you can.
Screen.
That's my nice cover slide.
Screen?
No, we'll go back to the There we go. So what we're talking about tonight is Leap Motion using HTML5 and CreateJS. So I'm just going to go through an outline of what we'll be talking about tonight. Do a little bit of intro. We're doing a lot of JS stuff. So we'll be looking at required.js and how we use that. CreateJS, obviously, how we use that. Looking at how do we get stuff out of Flash, CSX, the actual sprite sheets. What you're here for, looking at LeapJS and how do you actually use Leap Motion with JavaScript. And then talking a little bit about Leap Motion usability and best practices, which also may help you when you're actually thinking of your pitches tonight. So just sort of a quick introduction. I'm David. That's Yohei. That's Paul. We make up TVO's IdeaShaker Innovation Lab. So just a tiny bit about the lab, and this is sort of our official mantra. We are the internal idea incubation lab. We also do a lot of research and foresight. We look at sort of new technologies, especially disruptive ones, and see what their impact is to Ontario, to TVO, and seeing how we either create prototypes or eventually, at some point, also do actual operationalize them. The IdeaShaker Lab has been around for probably about 5 years now, and we've had some amazing, talented people, present company included, that have actually come through the lab. And just to kind of show you kind of what we've been working on over the years, this obviously looks a little bit old. But when TVO first started doing apps, it was the IdeaShaker Lab who did some apps, and we were lucky enough to be featured in the BlackBerry store. And this, in Pokeroo, Polka Dot Shorts was actually one of a very popular game we created for kids. We also moved into the sort of connected TV space, and so we developed an app for Google TV, and which also was thankfully featured by Google in the Google Play Store. Because we're a media company, we developed. It made sense for us to develop an app for our documentary, so we created the Doc Studio app for TVO. Again, once again, it was really well received by Apple, and we thankfully got featured by Apple. The latest sort of project prior to Leap Motion that we worked on was an app called Ping Pong. It was as a companion app to a documentary that was launched this spring, and the documentary was all about 80-year-olds playing ping pong in Mongolia. It's actually a really great documentary. If you haven't seen it, you have to check it out. It's called Ping Pong, Never Too Old for Gold. And the premise here, because TVO now, after the IdeaShaker develops it, it then goes into the organization. They develop apps further. The difference with this app was this was actually a physical app. So we decided that we wanted to take ping pong to the physicality of things. So what we did, we said, let's make your phone an actual extension of your hand, and you're actually going to physically play ping pong. So it's actually a physical ping pong game where you actually are playing with another person, going back and forth playing ping pong. You have to check it out if you have a chance. Once again, Apple loved it. It was one of the first and one of the few physical apps they had seen in the store here in Canada. Once again, we're fortunate enough that they actually featured us, and we had over 15,000 downloads within the first 2 weeks of launching the app. So once again, I've been blessed for the past year to work with a great team, and it's been around for about 5 years, and we've had amazing developers and creative people that have come through the IdeaShaker lab. So, LeapMotion. So, earlier this year, we were looking at sort of education technology, and we're looking at gesture and education, and then LeapMotion came out. And so we thought this would be a great chance for us to actually experiment and explore gesture and education, especially children's education. So we applied to LeapMotion. They accepted our application to be one of the pre-developers. So we loved it because it's all about active learning and embodied learning. Also, we liked it because it was going to be commercially available very soon. Compared to some other technologies that aren't as accessible to people, this seemed to be something that we actually really want to try out. So we had a chance to play with it over the past couple months. And on that note, I will hand it over to Paul, who will take you through, Paul Nyohe, who will take you through the entire process of what we did.
I've got my own mic. All right. Okay. You can come in, Nyohe. Sorry. Okay, thank you everyone for coming. So as you can see here, I know you might be tempted to scribble down everything we say. Don't bother with that because the presentation and any of the files that I'll be going through are available on my GitHub account, pmcmonagle/html5toronto-leapmotion-lessons, so you can... Oh, all right. Good stuff. So you guys can poke around through that. As we were going through the presentation, we realized there was quite a bit more that we had to say than we really had time for. So you'll find more in-depth stuff in the actual files there. I'm going to be going, like the bulk of the presentation is we're focusing on LeapMotion because we feel like that's sort of the new and interesting thing, and certainly the thing that we had the most fun with. So we're going to spend the most time on that. I'll talk a little bit about the other libraries we've used, but certainly for both of those, there's plenty of other resources online. So I feel like it wouldn't have made sense to go through those line by line. So the first thing I'm going to do actually is I'm going to show you, for anyone who doesn't know what LeapMotion is, I'm going to show you the device. I'm going to show you some of the demo things that come with the device that LeapMotion has made, and then I'm going to show you what we made for LeapMotion. And following that, it'll be how we made it for LeapMotion. So I don't know if you want to, oh, he's got the camera down here. So this is the LeapMotion device. It's really tiny. Essentially, it's you plop it down in front of you, and it'll track your hand and fingers in 3D space. So using the data from that, you can use it as a control mechanism and come up with creative ways to, you know, use your hands to start interacting with your computer, which is a whole lot of fun. If we want to go back to the laptop. So the when you right now it's sort of we've got a developer login. So using that, we got access to the LeapMotion software, which grabs data from the device. You can see it down in our dock here, and it comes with, you know, allows you to calibrate the thing, etc. It comes with like this visualizer where we can see it's tracking my fingers and stuff. What's that? Yeah, I believe right now it does up to 20 fingers. We're not going to cram all of our fingers in here to show that. But. And they've got a number of cool demos and stuff as well. So there's like this blocking demo, which is, it's basically the same idea. You can see the fingers, but it's definitely a lot prettier looking. And one of my favorites is apparently Google Earth you can control Google Earth using this thing, which is just fantastic. It's pretty sensitive, so I apologize if I make anyone nauseous while I do this. But essentially, like, you can go down, and let's see if I can, like, hone in on Toronto here. There we go. Yeah, I have. It's really, it's... And then you can see with the 3D buildings and stuff, if I tilt my palm backwards, it, there we go. We can, like, do flybys through the buildings and that sort of thing. So really, really cool stuff that you're able to do with LeapMotion. Moving on to our stuff, you'll see we've got this little caterpillar count icon on the desktop here. I'd like to say, actually, we're really excited to have done this. LeapMotion, whenever we were talking to them about how to best get into their early beta programs for our app, they actually suggested if we could find a way to, like, we built it in HTML5 and JavaScript, but they wanted us to find a way to package it as a native app. And we found on GitHub there's this thing called Node-Webkit, Node Webkit, and essentially that allows us to package our HTML and JavaScript game as a .app file that runs in Mac OS X. So that was really cool, and that's what I'm showing you right now. So here's the game we built. It's sort of a beta version. We haven't released it yet, but obviously the device itself, LeapMotion, isn't released either. But you can see it just, we've got this cursor that tracks our hand movements, and it picks up gestures as well. So if I tap my finger on this button, I'm starting to play the game here. And essentially this was an old educational game that we had on the website. It was originally built in Flash, and we said, okay, well, this is something that we could fairly easily take this, rebuild it in HTML5, and then use LeapMotion as a control mechanism for it. So it's meant for very young children. The idea is that it teaches counting, 1 to 15, and it's kind of like you can't, like, bump into these insects or, like, the back of yourself, but yeah, it's kind of a fun app. So what we're going to be showing you is essentially a little bit of how we made this. Okay, so here's a pretty high-level overview of how we put this thing together. Obviously, it starts at HTML5. So the HTML document is actually very tiny. Essentially, we've just got HTML5 doc type, we have a canvas tag, and we have one script tag that points to require.js. Require.js, I'll speak a little bit more about why we use that in a minute, but essentially that's what we used to structure all of our files. So it wraps everything else. Within that, we have JavaScript that uses CreateJS to write to the canvas, and we have JavaScript using LeapJS to pull data from the LeapMotion device and then send that to CreateJS, which draws the cursor to the canvas. And then you can see at the bottom here, as I said, the game was originally written in Flash. So we took all of those graphic assets and exported them as PNG sprite sheets to bring into CreateJS. So what is require.js? Require.js is a library that helps you write modular JavaScript. So modules being things, essentially what it sounds like, pieces of JavaScript that you can pull out and plug into other things. And it allows those modules to list dependencies, so a module can require other modules in order to run, and it grabs those other modules as it needs them. And so essentially, when we built this whole thing, we had many, many more JavaScript files than typically you would find in web apps. So at the end of the thing, they've got this Node.js tool, which will then pull all of those together based on the dependencies and package it up as one single JS file that's minified for you. Why did we use it? We actually have a long history of developing games in Flash, but certainly most kinds of game development, you want something that you're able to structure your application really well. So normally, like with Flash or say Java for Android, you have classes. And the way we built this, we built it in a similar way. We have files that act as classes, even though there's no class keyword in JavaScript. But essentially, game developers expect that each class will have its own file so that it's easy to find, that the classes will be organized into sort of a namespace structure, so there's no like collisions if you have similar names of your classes. They will list their dependencies, so you can see right from the beginning if you're missing things, then your project shouldn't run, it shouldn't compile. And finally, the example I gave here is for Flash, but really the reason I'm mentioning this is it has, you've got one document that links to what in Flash we call the document class. The reason that's important is without something like require.js, if you have a whole bunch of JavaScript files, you're going to have a whole bunch of script tags for each one. So to have one script tag that points to require.js, and then to have our document class, our main.js file say, okay, here are all of the other files that I need to run, really cleans things up for us. So we don't have to go into our HTML file and keep messing around with all of these script tags. Yeah, so require.js allows us to do all of that, which is really fantastic. Moving on, I'm not going to show any code for require.js or create.js, by the way. All of the code stuff I'm going to be showing is LeapJS, but the lesson files that I said are on my GitHub, those both use require.js and create.js, so you can poke around through those and have a better understanding of how we use those. But I'm going to talk about how we structured our app in terms of the CreateJS stuff. So what is CreateJS? For anyone who doesn't know, it's a library that makes developing for HTML5 Canvas really easy. It also includes good audio support. The terminology, again, we have a long history of Flash, so the terminology is similar, where you have things like a stage and display objects. And it enables preloading. So if your game is fairly large and you've got all these PNG sprite sheets and everything, you're able to load those in and have like a progress bar that'll tell you how many of your files have loaded before you start actually playing the thing for the user. So here, as I was saying, there's a similar terminology to Flash and CreateJS. Here's just a really basic example where essentially you have what's known as the stage at the root of everything. And attached to that, you will either have display objects. A display object could be a bitmap animation, text, or something that you've rolled yourself, which I'll show in a bit. Or it could be containers, which are just meant to hold other display objects. So you can create a hierarchy there. And then transformations and stuff that you apply to the parents in that hierarchy get applied to the children as well. So if you stretch your container, all the display objects that it contains will get stretched as well. So how that applies to the way that we built our game, you'll see that I've broken apart the basic elements of what exists on our game. Essentially, we have the stage is all-encompassing. It wraps around everything. You don't see it here, but I was talking to someone a little bit before the presentation where we have views that will then decide which display objects get drawn at a certain point in time during the flow of the game. And then we see the display objects here, the cursor, this big hand here. We had Leap Motion adapter, so that's what we are using to take the Leap Motion data from the device. We do a little bit of translation on that data to say, here's how it makes sense in the space of the canvas. And then it's got an instance of createjs.bitmap which is a display object, which we draw to the top of the canvas. Down here, we can see the entire caterpillar is a container. It's a class caterpillar that then just inherits everything from containers so that we can use all of the regular methods that normal CreateJS container would have. And inside of that, we have a head and multiple instances of body, which again are classes that we inherited from CreateJS.bitmap that extra functionality, things like telling the head that it has to follow the cursor. So that's, we're not going to get quite into the LeapJS stuff yet, but that's the require.js and the CreateJS portion of it. Again, if you want to look at the code for those, check out the lesson files. Moving forward, I'm going to introduce Yohei Yamaguchi, who's going to talk about the Flash CS6 sprite sheets and how we got those working with our game.
Okay, thank you, Paul. I'm going to a little bit talk about the Flash CS6 sprite sheet. As we mentioned earlier, our original game was built in Flash, and then there were a number of the animation was used like a timeline animation. And the Flash CS6 has a great new features, converting timeline animation to HTML5 ready. There are actually a couple ways to do it. When you, for example, Google a Flash CS6 CreateJS, it probably return a number of the results Flash toolkit for the CreateJS. Also, the other one is the sprite sheet generator. We used first toolkit for CreateJS because we were working on with the CreateJS. Toolkit for CreateJS is a free extension. It's built by Grant Skinner, who is a developer of the CreateJS. And in order to use it, you need to manually download and install into your Flash CS6. It's AS3 friendly, and then what it does, we didn't use actually the toolkit for CreateJS, but what it does, one of the features it does, extract all sounds files from timeline animation to convert it to separate MP3 format sounds files, which actually really helpful for us because we needed to take like a background sound of music and stuff like each separately. But our original game was written in a ActionScript 2, and then the way that our game was organized in the library was just simply it didn't work with our exported animation. So instead, we chose sprite sheet generator, and the sprite sheet generator is very simple and easy to use. You just go into the library and then select your movie clip. For example, you want to make the HTML5 ready, and then right click and then just set the couple of formats, and then it will returns like a sprite sheet PNG file and then sprite sheet JavaScript. When you do like a setting like a data format, there actually gives the option like easel.js. Easel.js is a library of CreateJS suite, which makes the HTML5 canvas to be Flash-like. And also, we chose this because each movie clip we needed to make the sprite sheet JavaScript. So this is an outcome. How we incorporate to our code. It was basically simply only two steps. First, we saved the sprite sheet PNG file into our image folder, and then also step 2 was just took the whole. As you can see, you can't see it. The JavaScript has easel.js. Okay, yeah. So we could have used whole JavaScript Flash exported it, but instead we just took the chunk of the code, this data easel.js format, because into our class file, because our class file was already optimized by our require.js, preloader.js, and then some other object-oriented programming way. So And yeah, we did whole this process to every animation in the game had, and then that's about it. Yeah. So FlashJS 6 is really amazing, HTML5 friendly. So I'll give it back to Paul, and he's going to talk about LeapJS.
You can keep the mic. Okay, so the moment we've all been waiting for, or at least I've been waiting for, just because it's so much fun to play with this thing. LeapJS, obviously if you don't actually have the device yet, this won't be of much use to you. But anyone can go right now and check out their GitHub repository, LeapJS, poke around in it if you really want to. At least a couple of people tonight I've heard will actually get some use out of this. So there's the repository if you want to start playing with it tonight. It's important to note for if you're developing with LeapJS, you're going to want to think about browser support. Essentially, browser support right now, because the way LeapJS works is it uses WebSockets to pull data from the device. It actually connects to localhost on the client's machine to grab that data. And so that's why you've got the leap.app running, which actually provides that to LeapJS. So that said, if your browser doesn't support WebSockets, LeapJS isn't going to work for you. I don't know if you're going to be able to see all the detail on this chart here, but as I said, go to caniuse.com/WebSockets if you want to do it yourself. For Firefox and Chrome, it looks really good. It goes quite a ways back, but obviously less than IE 10, you're going to have some issues. It's worth mentioning that I actually poked around through the LeapJS source code, and they include a little bit of code that looks like it's meant for a Flash-based polyfill, where the idea would be that instead of using WebSockets, Flash would make the socket connection. That said, it's not quite working yet. The issue seems to be that Flash, in order to make socket connections, requires a policy file to be delivered from the server. But if you're connecting to localhost, I'm not really sure how that pans out. How do you deliver a policy file from somebody's client machine? So I set up, I created an issue for it on GitHub. Maybe they'll sort it out. Maybe they won't. Maybe some of you, any one of you might be able to figure that out for them. It is GitHub after all. But until that happens, you're limited to WebSocket support. Now to get coding. All right. So what I'm going to show you is basically how easy it is to grab data off of the device using LeapJS, and I'll show you a little bit of the types of things that we can actually get. So hopefully, as you're thinking of your ideas of what can you do with this, you'll look at the data and say, oh, actually that might be possible, and it might be possible using LeapJS. So, oh, yeah, I meant to show you this a little earlier as well, but back when I was talking about the way we set up our game and our class files, I can actually show you if we go into, I've got a copy of it on the desktop here. So I've actually got it, as I said, I've got it organized into sort of a namespace. So we had TVO kids, caterpillar count. This one? Well, I can probably do it down here. All right, sorry. Okay, so you can see we've got it TVO kids.caterpillar count, and then within here, as I said, I've got a number of views that controls what's getting displayed at any given time. And then in our game engine, as we saw, I've got caterpillar, head, body, that sort of thing. Anyways, so LeapJS. So what I'm actually going to show you right now is over here, we've got a sort of dumbed down version of our game that I made. And this is what you're going to get if you check out the files I hosted on GitHub, is essentially how to put this together. And you'll notice it's following the mouse around. So when we built this, essentially we said the easiest path to this is we'll build the game first, and we'll build it in a way that we can pull out the controller that handles the mouse, and we'll plug in LeapMotion. So getting into the LeapJS stuff, essentially all I have here is it's a pretty blank page. It just has LeapJS loaded in. If we take a look at the source here, so all we're looking at is a couple of script tags for LeapJS and CreateJS, and then there's Canvas here. How nostalgic if you have no support for Canvas. And all I'm going to do is head into the console, and I'm going to show you how easy it is to start getting LeapMotion data. So essentially, when you've got LeapMotion, or sorry, when you've got LeapJS loaded in. What's that? Sure. Is it not big enough? All right. That's pretty big. All right. All right. Yeah, I think it's fine. So you've got this Leap object, and the really important thing attached to this is this loop method. And really all you have to do is you give it an anonymous function. The anonymous function takes a frame, and then if we log that frame, we're going to see a whole ton of data being spit out by the LeapMotion. So obviously here, it actually spits them out at a really phenomenal rate. So you're either going to want to set breakpoints, or if you want to, I'm just going to refresh it, and as well as the frame, you can give it this done, which is a method that you would call. So I'm going to log the frame again, and then done. The loop won't run again until you've called done. So that allows us to do something like, let's say every 2 seconds. And then you can see it's spitting them out a lot slower now. So if we want to open any of these up, we can start to see any of the data that you would possibly want from your LeapMotion device is attached to this frame object. So we've got things you can just see really quickly here. The really important ones are generally these arrays, where we have an array of fingers, an array of gestures, an array of hands, pointables. And this is, like, if you start thinking about what's actually going on top of the LeapMotion, obviously your hands is your physical hands that you would be waving over top of the thing. Fingers are your fingers that are attached to your hands. Tools down here could be either fingers, or sorry, actually tools would be if you have a pen or any long thing that isn't attached to your hand that you want to wave around in front of this. That's going to be in the tools array. And then pointables is both fingers and tools together. So if you don't care whether it's a pen or your finger, you'd look at pointables. So generally what we did while we were developing this is we would do something like, okay, I want to do something with the hands. So we do, again, it's leap.loop. We give it this anonymous function, take the frame in, and then we do something if frame.hands.length is more than 0, then let's get just the first hand in that array or something like that. So you can see, because I was bending over and I was over top of the LeapMotion device, it already spit a bunch out. And actually, as I scroll down, it spits out more because my hand is above it. But let's just look at any one of these, I suppose. So if you don't care which hand your fingers are attached to, you can pull the fingers array right off of the frame object. If you do care what hand your fingers are attached to, you can see each hand has its own array of fingers. You can also see palm normal and palm position. So if you remember the Google Earth demo I showed you where I was raising my hand and lowering it, that, like, I didn't build it and I haven't talked to them about it, but I'm willing to bet that that uses palm normal and palm position to figure out how you're angling your hand and moving it around. We also have velocity, which is a really fun one, and there's actually a fun little demo that I want to show you for this, but essentially the frame object is able to compare itself with the previous frame object, so you automatically get velocity of anything that the frame sees, so how fast your things are moving there. And my console's not clearing, I think, because it's lagging a little bit. But if we go into some of these lesson files, I included it here. I believe it's 2.2. Yeah, that's the one. That's the one we want. I'm going to copy that. So hang on, I think my browser window crashed because I printed out too many giant objects. So I'm just going to grab this. As you can see, it's leap.loop, the anonymous function. It takes in the frame. And all I'm doing here is I'm saying if we have anything in that hands array, I'm leaping through them, and then I'm checking the palm velocity along the z-index to see how fast it's moving. And originally I had this set at 9001 just to be funny. That's actually really high and is hard to do, so I brought that down a little bit. But what this gives us is a fun little demo where I should also note I don't want to be responsible for anybody punching their computers. So don't. It's included just as a fun little thing, but don't punch your computers, please. Essentially, if I run this and then I move my fist fast over top of the thing, you'll see the number goes up. Falcon punch. Whereas if I do it slowly, we don't get anything. And then I also included one for the finger. So if I have my index finger out, come on, Falcon poke. So. All right. Also, please don't anyone submit that as their idea. That would be kind of lame, really. Okay, so moving on. So you've seen what the frame object is. Getting fingers and pointables is the exact same as getting hands. You just look through that array, and then you can spit it out into the console and see the same sorts of data. So you get, with fingers and pointables, you get the position of the tip. You can see how long your fingers are. You get the length of the pointable. And you get velocity and direction as well, which is pretty cool. The last thing is gestures. And how gestures works is it's basically the same as well. There's one thing that needs to be added in. So whenever you do leap.loop and you give it this anonymous function, it does actually support, in front of that, you can give it configuration objects. So for gestures, you would do enable gestures true. And then from there, we can do the same sorts of things where if frame.gestures.length is more than 0, let's just spit out the first one. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . So if I start doing gestures now, oh, you can see it interpreted that as a swipe. So I'll do like, oh, it keeps saying swipes. Very carefully, I'll do some screen tap, key taps. You've got screen taps. As you can see at the bottom there, that's if you poke towards the screen. And you've got like this circle gesture. If you move your finger in a circle, it picks those up. And you'll notice it's spitting out a whole ton of these. What we actually get here, if we look at the last one, and this is really important for gestures, you'll notice the state here says stop. And if I go up into one of these in the middle of the pack, we've got the state as update. And then if I can find the beginning of that swipe, it's right here, we'll see state start. So normally what you would do, you might not care about all of the updates. So what it does is it sees that you're starting to swipe, and it will give you that state start, and you've got where the swipe has started, and then you can see where the swipe has ended with state stop, and then any loop that has run between those 2 points, you're going to get an update on where that gesture is happening. For the most part, I don't really think the updates would be useful data, but maybe you can come up with really creative uses for it. For the most part, you're probably going to want to look at the start and stops of those. Stop, I would say, is probably the most important, because if I can find the key taps up here, because it's just a quick little thing, maybe I can just do another key tap. There we go. So you see, you only get one key tap, and it gives you state stop. So if you're going to look for key taps and screen taps, state stop, some of the longer ones like the circle and the swipe, you've got all of these update things in between start and stop. And that is, that's the basics of how to grab data off of your Leap Motion device. So moving forward, if we want to go back to this example where I've got this simple little caterpillar following our mouse around, inside the lesson files, you're going to see this is I created this. I called it. Let's see if I can zoom in on this a little bit as well. Is this big enough? Are we good? All right. So you can see this is a pretty redundant class. I called it CJS mouse adapter. All it does is spit out your mouse and your mouse X and Y, which you could have done anyway without needing a separate class for that. But as I was saying, with writing JavaScript in a modular way, you're able to pull things out and plug other things in. So the reason I did that, the reason I created that class is I pass an object that has an X and Y into the caterpillar that says this is the thing you're supposed to follow. So all I did was I replaced that with the CJS Leap Motion adapter that I wrote. And what this does is it's certainly more complicated than the mouse because you're not just getting a straight X and Y value. The data from the Leap Motion device, as I was just looking at it in the console, I was saying if my finger's over here on the x-axis, I was getting minus 260. Over here was positive 260. 260 of what? I'm not sure. Maybe centimeters. And then it was going from 0, very close to the thing, to about 600 up here. And then it was minus 260 to 260 on the z-axis as well. So if you're looking at that, and you're looking at, you know, you want to say like, okay, if my finger's at minus 260 and 600 in the Leap Motion, I need that to be 0, 0 on the canvas. So that's where I've got just a little bit of translation going on, where I make that make sense. And then I also added in a few other events to this class that would make sense for when you start developing for Leap Motion. Things like we realized that people, certainly children, because this was built off of a kid's game, they might not fully realize how to use the device if it's brand new. So we have an inactivity timer where we look for, okay, have we seen hands or pointables in a little while? I've got it set to 15 seconds right now. So if we haven't seen those, then we spit out an event from this adapter class that says, hey, we haven't seen any activity. And then the view will take that event and display a little prompt that says, wave your hand over the device, what are you doing? And we also have a disconnect timer set at 5 seconds. And that's one you're going to want to pay attention to, because if for whatever reason you lose the Leap Motion device, Leap.loop simply won't run if it can't find the device. So all the disconnect timer does is if it reaches its end, it's going to throw out an event that says the device looks like it's being disconnected. And again, our view will pick that up and display something to the user. So inside of Leap.loop, we just perpetually reset that timer so that it never reaches its end so long as Leap.loop is running. And that's how we integrated Leap Motion into our game. So back to the PowerPoint. Yes, LeapJS also works with Node.js. I do have a neat little bonus demo if we have time for that, where I have it spitting out ASCII text in your terminal for all of your fingertips. It's pretty cool. But yeah, for Node.js, you can actually use the Node package manager. So you do npm install LeapJS, and it sets that up for you. So that's really cool if anybody wants to do some stuff with Node.js and LeapJS together. I don't know if we have time for that or not. Do we? Do we want to see this? Do we want to see this? Okay.
No, I don't want to see.
I'm nervous. I didn't test it as much as the other things. But what are you looking for? What's in files? There it is. ASCII point map. Is the text big enough on this? No? Say when? Is that good? We're good? Keep going? Oh, because we've got
You got the hands up too.
right. Yeah, that should be fine. So Node ASCII point map.js, and I'm gonna tell it just what do we want to tell it? Maybe hey from HTML5 Toronto. There it is. So it's following my finger around, and actually it might work. It might work a little better with the shorter string. So maybe I'll just try. Maybe I'll just try HTML5 rocks. There we go. So there's like follows my fingers around in the terminal, powered by Node.js.
You don't want to see.
All right. So, sadly, that's the end of our presentation. I guess we have time for questions now. David, you want to come back up here for the questions? Oh. Yes.
What was the hardest part? Repeat the question.
What was the hardest part? The hardest part, I would say, was dealing with an API that was growing as we were using it. So we ran into problems where, for example, they said, okay, this should work with all of the browsers that support WebSockets. I said, okay, great. Normally I do my development in Chrome anyway, so I was like, okay, this is fine. let's try this in Firefox. And then what we realized was it wasn't working in any other browser than Chrome. So I'm sitting there like, okay, well, the guys who wrote LeapJS are very smart. What could I be doing wrong? So I'm like banging my head against it. And then I go check the GitHub thing, and sure enough, there's an open issue. Small bug where right now it only runs in Chrome. Of course, it was fixed a couple days later. It was just really bad timing on both of our parts, I guess. That here I am trying it on Firefox right when their latest revision broke it on all of the other browsers. But it was things like that where you spend some time on it, and then all of a sudden you go back to the GitHub repo, and they fixed it already, and you're like, oh well, I just spent all this time trying to figure it out.
Also, I guess, developing something brand new for an audience that's never seen it, and you really have no clue how they're going to interact with it. And especially if you take that from an adult down to a 4-year-old. Understanding how is a 4-year-old actually going to interact with a device that they've never seen before, they're not used to it, they have no concept of what this thing is, and then also trying to build instructions before you actually are able to sort of test it with an audience. So that was another thing, is the usability and user testing, is understanding your audience. That's, I think, another thing that we can say is that understand who your audience is, what they want to do before you actually sort of develop this thing. And that's something that we learned as we went, and we did a lot of testing. We brought in a lot of kids into the lab and actually put them in front of the device and said, okay, go for it and try it and see what they do with it, then take notes and then adjust it and change it as we went. So a lot of testing with human testing, with actual people, seeing what they'll actually do with it.
So how long did it take to do this, and how do you manage this sort of project where
Okay, so the question was, how long did it take for us to do this, and how do we manage a project, I guess, one that's new and changing, that we haven't really developed with before. So doing as I said, we developed it in CreateJS and RequiredJS first for use with the mouse. Just doing a straight Flash to HTML5 and JavaScript conversion, it only took us a couple of weeks to get a polished product out. Adding in the Leap Motion stuff actually didn't take that much longer because, as you saw, all of the data that you want to pull out of there went really quickly. So that was, I would say that was maybe 3 days plus another 4 or 5 days spent trying to actually figure out the things that were changing as it went. So 3 or 4 weeks overall total from initial thinking about it, planning, and coming up with the thing at the end. Plus we actually did quite a lot of time testing, so maybe another week on top of that where we had people brought in and to actually play with the thing. How we managed that, luckily for us, the new parts, the Leap Motion stuff, I took those on personally, and it wasn't a lot that we had to delegate those to a lot of other developers. So it was pretty easy for us to say, okay, I know how developing in RequiredJS and CreateJS works, so you guys can do, you can work on the caterpillar's head or whatever, and then I took on the fun part of LeapJS. So I guess that's just in my confidence. I knew I could get the LeapJS portion done in time, and it did turn out to be fairly easy, apart from those little hiccups along the way. I don't know if you want to speak to some of the project management issues around there.
So it's being the innovation department, we do get a little more leeway, even though for some reason the last few projects, like the ping pong and this one, we've decided that we're going to go against hard deadlines, which makes innovation a lot tougher. But as Paul mentioned, one of the big things was take out what you know and what you know you can do first. So break out everything you think you're going to have to do, figure out the parts you know and the parts that actually think and how long you think it's going to take, and then work on the actual black box. So then look at, okay, well, Leap Motion was our big black box. Well, how long is this going to take? So we kind of exponentially estimated how long it's going to take, and then we went backwards. Ironically, a few of the things that caught us by surprise were things we thought we'd already done. Like, for example, voiceovers. As we developed the project, we are like, okay, well, we'll grab this from the original asset, and then we're like, oh, wait a minute, the original asset talks about Leap Motion with your mouse. Okay, well now we got to make a new voiceover. And oh, well wait a minute, we have to do this and that. So there's these little things that kept coming up for us. Now what we had to do was we had to kind of take a look at the entire process, figure out, okay, we know that it's going to take us at least 3 weeks plus X, kind of make a leap of faith, to use sort of slightly a pun there, of how long that would take, and then sort of cross our fingers at some point.
Yes. So with the device we have right now, we are registered as developers for Leap Motion, and we have a login that gets us access to the SDK and everything that comes with. And in terms of emulator, as we saw, getting the data out of this thing, I don't really see why you'd need an emulator there if you have the device. Sorry. I guess he means for everyone who doesn't have the thing, which is a lot of people. I'm so privileged in our department. I'm sorry. Yeah, you need a developer login to do this, and if you have that login, you have the device. That's just kind of they go together right now. I don't know if they have. I think they're focusing on actually releasing the device so that you can go and buy one for yourself and won't need an emulator. July. Yeah.
So right now it's still in beta. So originally Leap Motion was supposed to launch the end of May. They then delayed that for, how many here have pre-ordered a Leap Motion? You're probably really pissed off right now, I think, the fact when they delayed it. So they delayed it for a little bit for some pretty good reasons. They want to do a little more like we did. We said the biggest thing we did was testing. And so they also want to do a lot of testing. So they've delayed it. They are now going to what's called a beta test. So anyone who is able to submit, who actually has a device, submit it, will now go through a beta session. And that's where, from we've been told, other developers that have one will actually be able to test it. It also depends on what your game is. Like, as Paul mentioned, we've made it modular. So theoretically, with our game, you could test it with the mouse first and then say, well, I know it's going to work with the mouse. Therefore, because of all the array that Leap Motion has, I know I can just take out the pointable, put in the X and Y, put in the pointable, and I know that it's actually going to work. So if your game obviously is like crazy, you're not going to be able to emulate that at all. But if you're thinking of a simple game like we did, you might actually be able to do that. And actually, to answer your question again, what we, again, is that we try to do incremental. So we decided that we're going to try a simple game, figure out the testing, figure out the usability aspects of it, figure out, because we do a lot of children's games, figure out the research behind that, and then move forward. So that's why for us, we took a little less risk than, for example, someone like T-Hen and Lax, who did, if you've seen the whole Google thing that they did some crazy stuff with that. So we were a little bit on the safer side, and we really focused in on the actual sort of the children's educations and that experience part of it. So that's why we didn't have as big of a black box as, say, someone like T-Hen and Lax would have. No, in that, like, for example, the question was that you probably want to do a proof of concept first, and for ping pong, that's exactly what we did. We actually proof of concept says, okay, we want to make this physical game, let's proof it. We realized that we didn't have enough time to develop it completely, so we actually hired a company. This time we did that. We actually first started doing that. Actually, I guess that I should have brought that up. Yohei actually first started with it, and we actually figured out all the stuff we could do, and we did work backwards that way. We figured out, can we get data from the actual device and then work backwards that way? They can actually talk to that even better.
Don't forget the Node.js thing. It's the first thing I did with Leap Motion. So that was actually on a Friday afternoon. I was like, let's try and do something cool. We just got in the thing. So that was maybe an ad hoc kind of proof that yes, we can actually do this. It's usable and we can do it fairly quickly.
So for us, that also started from, we have these sort of things called Innovative Fridays, where like that we developed with the Google app and Apache and so forth, and that was kind of started as that. We're like, can we play with this? How far can we get? And then Paul did the whole thing with that, and then we're like, hey, wait a minute, we actually have potential to actually blow this out completely. So then that's where we started then iterating, saying, okay, now let's move forward, let's figure out what we know, what we don't know, and then make a big project of it. So in this case, compared to something like the ping pong app we did, there was a little less risk for us this time because we had a lot of the key pieces in place that we knew a little bit more at last one. But also that's kind of the fun part, is not knowing. But from a project management standpoint of view, it is a little bit of a nightmare to some degree and a little bit scary, and I do lose sleep once in a while at night, especially when we actually have hard deadlines. And our hard deadline was supposed to be May 19th. And so that was kind of, we're moving forward. And so in some ways we are a little thankful that we've had a little more time to do a little more testing on it. So, answer your question?
We haven't tried. Sorry. Yeah, right. The question was: is it possible to connect more than one to a machine at once? We've heard that before, actually, where we were thinking of things like maybe you could have one that sits in front of you down here, and then like tape another one to a wall or a stick or something, so it points this way.
When Matthew came to the lab, that's what he actually asked.
That was Matthew's idea.
Matthew, and he's like, "Can we do multiple?" So we want to do it. We haven't had time yet, and we actually have a few devices because we also do testing with children. So they actually gave us a couple devices because we test with groups of children. So that is one of our Innovative Fridays at some point when we have a chance, but. We've asked, a few people have asked that. Matthew asked us that right away, and when he came in to see the work we're doing in the lab. But we will eventually, at one point, try it out and see what happens. We have no clue if it's going to work or not.
Well, it's meant to be sitting on your desk. So whenever you get data out of this thing, it works by infrared, so it reflects off of things and then it picks those up. So theoretically, it's going to pick up that light. Like, it's not affected by gravity. It doesn't matter where the thing is. But in terms of the data that you get out of it, your X, Y, and Z axis are relative to how it thinks it's supposed to be. So if you think your x-axis is going to be this way, and then you've got the thing, flipped upside down or something, it's going to be reversed, right? So if you account for that, then I'm sure you could still do something with that, but you just have to keep those sorts of things in mind.
We have actually, as we were doing research for this, we did actually see a company in Germany, actually, that they have a device, actually, that is pointing at you. It's kind of like a camera-style thing, so theirs is a little different. And to talk about how it's positioned, one of our first sort of big brain ideas was actually do a rock, paper, scissors game. And so we're like, oh, that'd be cool if we use it. And I really love WebRTC. That's the big joke, because I love WebRTC. I'm trying to find a way to put it into one of our projects. And so we thought, well, let's make a kind of a two-player rock, paper, scissors game. The problem, as you'll probably realize, is that you have rock, you have paper, and then you have scissors. And as Paul mentioned, the leap motion goes upwards. So this doesn't really mean anything. Like this, in theoretically, this and this are almost the same thing because it's one pointer. You have to go like that in order for it to actually be scissors. So for us, if we want to keep it true to the game, and those are things you'll find out too, that really this is one piece. This is kind of like the same thing. It's sometimes hard to distinguish between the two. So we had to figure a way. So that's kind of one problem, or one thing you have to realize is that it is upwards. So this is one whole piece. So if you try to do this and this, it's another thing. And we've also started playing around and thinking about usability, as in with, for example, like sign language and stuff like that. And so we started looking at that and seeing how potentially we could do that. But again, you may run into some of the same problems with that. So, but good question.
You guys were building a 2D app or a 2D interface for, like, it's a 2D game, right?
Yep.
What do you see as challenges if you're going to be doing things for 3D?
Right. So, as we said, the idea of an emulator wasn't really important for us. The way it was developed, in that, you're right, it was a 2D game. So for us to pull out the mouse and throw in leap motion was really easy because we're only worried about X and Y. If you're starting to look at things like, using the Z-axis, if you're using the rotation or position of the palm, those sorts of things aren't, you're not going to get that out of a mouse. So at that point, you can't really develop your thing without leap motion. One of the things I thought of doing if we were to do something in 3D space was You could have the mouse control X and Y and then just use 2 arrow keys to spit out a fake Z index for you so that you could still kind of do that. But it still wouldn't keep, it wouldn't account for things like gestures or your palm. But really all of that becomes a moot point once you get the device, because all of that data all of a sudden becomes available to you and really easy to pick up and use.
One of the demos we did have was actually done in Unity. So it's actually a 3D demo where you actually can pick up stuff in 3D space. So I'm assuming at that point, we haven't actually played with that stuff yet, but I'm assuming there's probably a whole nother sort of API or a plugin for Unity if you want to play in the 3D space. And also, actually, someone actually created a Flash API as well. So you actually can go straight from Flash into LeapMotion as well. It's not supported by LeapMotion, but it's done by developers. So there's many ways. For 3D, the way we've seen right now is either you do it, like, for example, in C++ or Java or some of the hardcore languages, or Unity, but we haven't actually played with it yet. And we have apparently time for one more question, if anyone has one question.
You mentioned you can have like a brush pointer or something. You can see that pointer. Have you had any experience with sort of interference with a larger object?
So the question was, we talked about using tools such as a brush or pen, and whether or not we've had problems with interference with even larger objects. In actual use cases where we've got the device sitting on a table in front of your computer, it hasn't been an issue. It's able to very clearly say, okay, here are your hands, fists, and fingers, and there's not usually anything else in that space. But as I was developing this, actually, it was somewhat of a problem for me in that my desk is right next to a very large window, and because it works off of infrared sunlight, very bright sunlight can sometimes interfere with how it works. So as I was developing this, I was actually trying things such as putting it under my desk to try and hide it from the sunlight, but I realized that having that ceiling there right above the thing, like I'd sit it on top of my tower and try and like use it that way to hide it from the sun. But that started interfering with the data I was getting out of it. So you're going to want to not have like don't put it under your desk so that there's a ceiling here basically. But the way it's meant to be used, it hasn't actually been an issue. So for if I was holding like say my mouse or something, I haven't tried it. I mean, certainly we've got the thing plugged in. We can try that right now.
But as Paul does that, the one thing you do have to remember that because it's infrared, lights are also a problem to some degree. So there's what's called a robust mode. So if there's too much light, it actually sort of dims down. As well, there's also if it's smudgy, there's sort of like a smudgy mode, like if you have like smudges on the device. So that's another thing you have to watch out for. Make sure the device is clean, and the lighting as well. And obviously the office lighting isn't going to be your home computer lighting. Does it work?
You can see it sees 2 points there. I think it actually picks up. It's either my pinky finger coming off the bottom of the mouse, or maybe it's the
water bottle,
the bit of wire here. But it doesn't seem to care that I have a mouse in my hand. Water bottle, same kind of feel. Yeah, it doesn't seem to care about the water bottle. Yeah. I mean, if I'm if I'm covering the tips of my fingers, maybe it's an issue.
But can you do the water bottle and your fingers?
I thought that's what I was doing.
So, like one hand with water bottle, one hand with fingers. That's what I mean.
Oh,
sorry.
Yeah, that's no problem.
There you go.
It doesn't care at all. All right.
How about another round of applause, TVO?
So thanks again. Seriously, it's been an absolute honor having you guys on, and seeing what you guys are putting together and seeing what you guys are building is absolutely phenomenal. So truly, thank you for that. Appreciate it.